So write this problem. So a company stores its products at 4 cities, A, B, C, and D. To supply the products to 3 companies, P, Q, and R. The shipping costs per ton in 100 rupees are given below. Okay. So a company stores its products at 4 cities, A, B, C, and D. So these are the origins. And it supply the products to the 3 companies located at 3 places, P, Q, and R. So these are destinations. The shipping costs per ton, for 1 ton, in 100 rupees are given below. So write this table. Okay. For example, this entry means from city A to company P per 1 ton, transportation cost is 700 rupees. So this is 7 means in 100 rupees. Okay. So that is the meaning of this. So capacity 90 tons at first city, 50 tons at second city, 80 tons at third city, 60 tons at fourth city D. These are the available amounts. And demand. So required amount for first company P is 120 tons, and for second company Q 100 tons, and for third company R 110 tons. So these are the requirements. So demand means requirement, capacity means availability. Okay. Right. Because of railroad construction, shipments are prohibited from city A to company B. Okay. So because of repairs of road, the transportation is not possible from city A to company P. So this transportation is not possible. That means this transportation is not possible. Okay, you have to keep in mind that one. Next, find optimum distribution for the company. And also, are there multiple optimal solutions? If yes, identify them. So are there multiple optimal solutions? If yes, identify them. Okay. So this problem involves 3 concepts. First, unbalanced problem. Second one, prohibited shipment, and multiple optimal solutions. Okay. So this problem involves 3 concepts. First one is unbalanced transportation problem concept. Second one is prohibited shipment, and third one is multiple optimal solutions. So 3 concepts covered in this problem. Okay. So as usual, first to solve the problem, first to verify whether the problem is balanced or unbalanced. First to find sum of available amounts, sigma AI equal. So sum of all these available amounts. So 90 plus 50 plus 80 plus 60, that is 280. Next, sum of required amounts. So sum of these 3 amounts, 120 plus 100 plus 110, that is 330. So both are not equal. So sigma AI not equal to sigma BJ. The problem is unbalanced. Okay. So the given transportation problem is unbalanced problem. We have to balance it. How do we balance? First, compare these 2 values. Available amounts 280, required amount 330. That means there are more than required amount. Okay. So how do you compensate it? That means sum of available amounts is less than sum of required amounts. Okay. So sigma AI is less than sigma BJ. How do you compensate? We introduce a dummy row with capacity. Since the available amount is less than required amount, to overcome or to make balance, we have to introduce a dummy row origin with capacity is equal to difference of these two, 330 minus 280, that is 50. So introduce a dummy row with capacity 50 units. And for all these dummy cells, the transportation cost per unit is 0. as usual. The unit transportation cost to these dummy cells equal 0. Okay. So I find next, before going to solution part, observe the problem. Here, shipments are prohibited from city A to company P. Actually, from the table, from city A to company P, transportation cost is 700 rupees. But at present, the transportation is not possible from city A to company P. So we cannot consider this transshipment. Okay. So how do you consider this? So you are not supposed to consider this transportation cost 7 units. So in this case, we take, the transportation cost per 1 unit from A to P is very large price, approximately infinity. So we denote it by some capital M. Okay. So since shipments are prohibited from city A to company P, replace the unit transportation cost 7 by a large value capital M. This capital M is very large compared with all other transportation costs. Approximately this M is tends to infinity. Okay. So in case of prohibited shipments, suppose the cost is given, even though the cost is given, you are not supposed to take that cost. So you have to take a large cost, that is capital M, for that prohibited shipment. Okay. So in finding solution, you take the transportation cost for this cell as a large quantity capital M. Okay. So that is the way to handle the prohibited shipment and the transportation problem. Okay. Right. So method is not mentioned here to find initial basic feasible solution. So I use Vogel's approximation method, since Vogel's approximation method gives better solution, which is near to optimal solution. Okay. Right. Write the structure of this table. So you have to take the last column, that is available amounts, and introduce a dummy origin row, that is fifth row, with the transportation cost 0 and available amount 50. You have to add this extra dummy row in the table. And in the last row, take the required amounts. And in first cell, we have to take a large price capital M instead of 7 units. Since from this city to this company, the transshipment is prohibited. Okay, you have to take here M. Okay, so what are the steps involved in the Vogel's method? Already I have discussed. First, to find penalties for rows. So here write row penalties, and here write column penalties. What is first row penalty? Least cost to 5, next least to 10. So difference 5. Penalty means difference of least cost and next to the least cost in the row, and similarly for columns. First row penalty 5, second row penalty is also 5, least cost 4, next least 9. Third row penalty, least cost 3, next least 7, so difference 4. Fourth row, least 5, next least 7, difference 2. Fifth row, all are zeros, so difference is 0. Similarly for first column, least cost 0, next least 7, so difference 7. Second column, least cost 0, next least 3, difference 3. For third column, least cost 0, next least cost 4, difference 4. Okay. So identify the largest penalty. So what is the largest penalty? The largest penalty is 7. This is largest penalty is 7 for column 1. So largest penalty is 7 for column 1. So in column 1, least cost cell is, least cost is 0, so 5 1 cell. So least cost cell in column 1 is called 5 1 cell. This is. So for this cell, what is allotment? The corresponding available amount 50 and corresponding available amount 120. So minimum of these two. So X51 is called minimum of 50 120, that is 50. So right here 50 in 5 1 cell and circle it. right? Which constraint is satisfied? Since available amount 50, which is minimum, so that means all available amounts are transported. So fifth row constraint is satisfied. So cross off row 5. So observe first destination, out of 120 units, 50 units are transported. Remaining requirement 120 minus 50, 70. Okay. Then cross off row 5. Okay, right, next. Since row is eliminated, so that means column differences may change. So now the reduced transportation table is this, 4 rows and 3 columns. Okay. Since row is eliminated, that means cells are eliminated in columns. So column differences may change and row differences remain same. Again, repeat the same process. First column difference, least cost 7, next least 9, the difference 2. Second column, least cost 3, next least 5, so difference 2. Third column, least cost 4, next least cost 5, so difference 1. Okay, so these are the penalties for columns 2, 2, 1, and row penalties remain same. These remain same. So identify the largest penalty. So largest penalty is 5. We have type for largest penalty. The largest penalty occur for row 1 and row 2. So arbitrarily you can take either one, either row 1 or row 2. Arbitrarily I take the largest penalty for row 1. So largest penalty equal to 5 for row 1. So in the row 1, least cost cell is 1-3 cell. This is least cost is 5 in row 1. So that is 1-3 cell. For this cell, available amount 90 and require amount 110. So minimum of these two. So x13 equal to minimum of 90, 110. So that is 90. Right here 90 and circle it. Okay. So observe which constraint is satisfied. Total available amounts 90. So all 90 units are transported. That means row constraint is satisfied. So we cross off row 1. Observe it third destination. Requirement is 110. Out of 110, 90 are obtained. So still there is some requirement. So remaining required amount 110 minus 90, that is 20. Okay. So then cross off row 1. So then cross off row 1. Okay. Right. Now the reduced transportation table is these 3 rows and these 3 columns. Okay. So repeat the same process. Again, find penalties for reduced transportation table. Again, since here row is eliminated, so column differences may change. So first column difference, least cost 7, next least 9. So difference is same, 2. Second column, least cost 3, next least 5. Difference same, 2. Third column, least cost 4, next least cost 7. So difference is 3. And row differences remain same. Okay, right. Consider the largest penalty. So largest penalty is 5 again. So largest penalty is 5 for row 2. In row 2, least cost cell is, in row 2, least cost is 4, that is 2-3 cell. So for this cell, allotment, available 50 and requirement 20. So minimum of these two. So x23 equal minimum of 50, 20, that is 20. So right here 20 and circle it. Okay. Observe which constraint is satisfied. Observe the third column. Third column requirement 20. So here we have 20. So all required amount is obtained from second origin. That means column constraint is satisfied. Observe the second row. At second row, available amounts 50. Out of 50, 20 are transported. Remaining available amount 50 minus 20, 30. Okay. So then cross off column 3. Okay, right. Now column is eliminated. For the reduced transportation table, row penalties may change. Since column eliminated, that means cells are deleted in rows. So row penalties may change. Okay, right. First row, there are only 2 cells. So 9, 12, difference 3. So penalty is 3. 3, 7, difference 4. Second column penalty 4. Third column penalty 9, 5, difference 4. So row penalties remain same. Sorry, column penalties remain same. So row penalties are 3, 4, 4. Okay, right? So largest penalty is 4. Again, we have type for largest penalty. That is for row 3 and row 4. Arbitrarily you can take any one. So arbitrarily I take row 3. The largest penalty for row 3. So in row 3, least cost cell is 3 to cell. So in row 3, least cost is 3, that is 3 to cell. So this cell. For this cell allotment, available amount 80 and require amount 100. So minimum of these two. That is x32 equal minimum of 80, 100, that is 80. Write 80 in the 3 to cell and circle it. Observe which constraint is satisfied. Observe third row. Available amount 80. All 80 units are transported to second destination. That means third row constraint satisfied. Observe second column. Requirement is 100. Out of 100, 80 are obtained. So remaining requirement 100 minus 80, 20. Right here 20. Cancel 100 and write 20. Then cross off row 3. So cross off row 3. Okay. Right. So row is eliminated. So row is eliminated means column differences may change. Since cells are eliminated in the columns, so column differences may change. So first column, we have only 2 cells, 12, 9, difference 3. Next, second column, 9, 5, difference 4. Okay. And row differences remain same. This remains same. 3, 4. Again, largest penalty equal to 4. We have again type for largest penalty. So this is largest penalty 4 and this is 4. That is for row 4 and column 2, we have largest penalty. Arbitrarily, I take row 4. Okay, you can take any one, either row 4 or column 2. Arbitrarily, I take row 4. Okay. Next, least cost cell in row 4. Least cost cell in row 4. Least cost is 5. That is 4 to cell. So x4 to equal. For this cell, minimum available amount 60 and require amount 20. So minimum of these two. Minimum of 60, 20. That is 20. Write 20 in 4 to cell and circle it. So observe which constraint is satisfied. At the second destination, 20 units are required. All 20 units are obtained from fourth origin. So column constraint is satisfied. So we cross off column 2. Observe at fourth origin, available amount 60. Out of 60, 20 are transported. So remaining available amount 60 minus 20, 40. Okay. So then cross off column 2. So cross off column 2. Okay. So finally, we have only 2 cells. Among these 2 cells, take the least cost cell. The least cost cell is 4, 1 cell. Okay. For this, available amount 40 and require amount 70. Okay. So x41 equal to minimum of 40, 70. That is 40. Right here 40 and circle it. Observe which constraint is satisfied. At fourth origin, 40 units are available. All 40 units are transported. So row constraint is satisfied. At first column, available amount, sorry, require amount is 70. Out of 70, 40 are obtained. So the remaining requirement 70 minus 40, 30. Okay. So then cross off row 4. Okay. So finally we have only one cell. Finally we have only one cell. For this cell, available amount 30 and require amount 30. Okay. So our calculation is right. So only one cell, that is 2 1 cell. So x21 equal a minimum of 30 30. So that is 30. Write 30 into one cell and circle it. Okay. So finally we have to get only one cell, for which cell the corresponding available amount is equal to corresponding required amount. Then only the calculation is right. Otherwise the calculation is wrong. We have to start freshly with a new table. Okay. Right. So write the fresh table. Initial basic feasible solution is, we have to write the solution in first table. So remove the last column and last row. Take just origin rows and destination columns. So remove last column and last row. So this is initial basic feasible solution by Vogel's approximation method. So count the number of basic cells. 1, 2, 3, 4, 3, 7. So how many we require? 3 plus 5 minus 1. 8 minus 1, 7. So all basic cells are available. So this is, and all are strictly greater than 0. So this is non-degenerate basic feasible solution. Okay. Right. Now we have to optimize this solution by UV method or Modi method. Okay. So what are the steps? So we find U values for rows. So U1 for first row, U2 for second row, U3, U4, U5. Okay. And V values for columns. For first column V1, for second column V2, for third column V3. Okay. What is the relation? For a basic cell I comma j, Uy plus Vj equal Cij. Okay. Right. So observe the table, identify the column or row with more basic cells. Okay. So observe first column. First column involve 3 basic cells. So arbitrarily I take V1 0. Arbitrarily I take V1 0. Okay. So then consider this phi 1 cell. Consider this phi 1 cell. Cost is 0. V1 known. So 0 minus 0. So U5 is 0. Okay. Next, consider 4 1 cell. This is basic cell. Cost is 9. 9 minus known value. V1 0. So U4 9. Next, come to 2 1 cell. This is basic cell. Here cost is 12. So 12 minus V1 value 0. That is U2 12. Okay. Next. Next, 12 U2 is known. Consider this basic cell, and corresponding V3 is unknown. So here cost is 4. 4 minus known value 12. That is minus 8. So V3 is minus 8. Okay. Next, V3 known. So U1 unknown. So come to this basic cell. Cost 5. 5 minus of minus 8 plus 8. That is 13. So U1 13. Okay. Next. So U1 is known. Here we have no basic cell, right? Next, to calculate V2. V2 is unknown. In this column, U3 unknown. This is basic cell. U4 known. Okay. So consider this basic cell. Consider this basic cell. Here cost is 5. Here cost is 5. So 5 minus 9. So 5 minus 9, minus 4. So V2 is minus 4. V2 is minus 4. Next, here U3 unknown. And consider this basic cell. For this V2 known. So cost here is 3. So 3 minus of minus 4. So 3 plus 4, 7. So U3 7. Okay, so all values are known. Next, after this, find penalties for non-basic cells. For non-basic cell I comma j, Pij equal to Uy plus Vj minus Cij. So this is non-basic cell. Okay, corresponding cost 13, corresponding U value 13 plus V value 0 minus cost M. So 13 minus M. Since M is very large compared with all other values, so 13 minus M is negative. Since M is very large, since shipment is prohibited from first city to first company, so we take the transportation cost per 1 unit is approximately infinity. That is capital M. So M is very large, so 13 minus M is negative. Okay, so P11 is negative. Okay. Similarly, calculate P12. So for this P12, U value 13 plus V value minus 4, 13 minus 4, 9 minus 10 minus 1, so negative. Similarly, for this value, U value 12 plus V value minus 4, that is 8 minus 9 minus 1, so negative. For 3-1 cell, the corresponding U value 7 plus V value V value 0, 7 plus 0 minus 7, 7 minus 7, 0. For 3-3 cell, corresponding U value 7 plus V value minus 8, minus 1 minus 11, so negative. Next, for 4-3 cell, for this cell, U value 9 plus minus 8, 1 minus 7 minus 6, negative. For this cell, corresponding U value 0 minus 4 minus 0, negative. For this 5-3 cell, corresponding U value 0 minus 8 minus 0, negative. Okay, so observe, for all non-basic cells, the penalties Pij Pij's are less than or equal to 0. Here this is 0 and all other are negatives. Okay, so optimal condition. So all Pij less than or equal to 0. So optimal solution is, we have to write basic cells. This is basic cell, that is 1-3 cell. So x13 equal to 90 and x21 equal to 30 and x23 equal to 20 and x32 80 and x41 40 and x42 20 and x51 50. So this is dummy. So x51, this is dummy cell. Since this is dummy row, so this cell is dummy cell. Okay, so this is optimal shipment. And minimum transportation cost equal, take the sum of products of unit transportation costs with number of units transported. Okay, so first 5 into 90, this is 5 into 90 plus 12 into 30 plus 4 into 20 plus 3 into 80 plus 9 into 40 plus 5 into 20. Okay, so total this, simplify this, you get 1590. Since the costs are given in hundreds, this is 15, 90, 100. So that means 1590 into 100. 15, that is 1,59,000 rupees. Okay, so this is minimum transportation cost. Okay. Right. Now we have to check whether the problem has multiple optimal solutions or not. So for that, similarly, in simplex method, what is the condition for multiple optimal solutions in the simplex method? In the final simplex table, for a non-basic variable, if delta j is 0, then the problem has multiple optimal solutions. So in the final simplex table, one of the non-basic variables has its delta J value 0, then the problem has multiple optimal solutions. That is the condition in LPP. Similarly here, in transportation problem, the condition for multiple optimal solutions is for a non-basic variable or one of the non-basic variables, its penalty, that is Pij, is 0, then the problem has multiple optimal solutions. Okay, so in that case, that non-basic cell is taken as entering basic cell. Okay, next, alternative optimal solution. So this is the previous table. So observe for non-basic cells. So for non-basic cell 3, 1, for non-basic cell 3, 1, P31 equal 0. Okay, since for a non-basic cell 3, 1, P31 equals 0, so then there exists an alternative solution. So the problem has multiple optimal solutions. Okay, so this is the condition for existence of alternative optimal solution or multiple optimal solutions. That is, for a non-basic cell, its penalty, that is Pij, is 0, then the transportation problem has multiple optimal solutions. So such cell is taken as entering basic cell. So this 3,1 cell is taken as entering basic cell. Okay, so this cell is taken as entering basic cell. So this is entering basic cell. Okay, so from here, same process. So there exists a unique loop starting from this new basic cell. You have to identify that. So clearly the loop is start here 3,1 cell, then come to 4,1 cell, from here to 4,2 cell, from here to 3,2 cell, and 3,2 cell to 3,1 cell. So this is the closed loop. Or you come in this direction also, from 3,1 to 3,2, 3,2 to 4,2, 4,2 to 4,1, and 4,1 to 3,1. So whatever the direction, either clockwise or anti-clockwise, the loop is unique. Okay, right? So next, alternatively assign plus and minus signs for the cells in the loop. Starting cell plus, next this is minus, this is minus, and plus, this is plus, and this is minus. So alternatively assign plus, minus, and plus, minus to the cells in the loop. Okay, right. So after that, what are the negatively signed cells? So this is negatively signed cell. That is 3,2 cell is negatively signed cell, and 4,1 cell is negatively signed cells. These two are negatively signed cells. Among these two cells, what is the minimum of allocation? Here allocation is 40 in 4,1. In 3,2 allocation is 80. So minimum of these two is 40. That is 4,1 cell. So 4,1 cell is leaving basic cell. 4,1 cell is leaving basic cell. So in the closed loop, we consider negatively signed cells. Among those negatively signed cells, take the minimum value. The corresponding cell is leaving basic cell. So here 4,1 cell is leaving basic cell. So 3,1 is entering basic cell. 4,1 is leaving basic cell. How do you find the new solution? So take the structure of the table. This is previous table. So here 3,1 is entering cell. 3,1 cell is entering cell, and 4,1 is leaving cell. Okay, so we have to add 40 to positively signed cells. Since minimum allocation among negatively signed cells is 40, we have to add 40 to positively signed cells. So this is positively signed cell, that is 3,1 cell. Add here 40. So previous allocation 0. So 0 plus 40, 40. So 3,1 cell right here 40. Okay. Before that, write this step. Add 40 to positively signed cells and subtract 40 from negatively signed cells in the loop. Okay. So first 3,1 cell is positively signed cell. This is entering basic cell. Add here 40. Previous allocation 0. So here 40. And circle it. And another positively signed cell is 4,2 cell. This is 4,2 cell. This is positively standard cell. Previous allocation is 20. Now add 40. So 20 plus 40, 60. That is 4 cell 60. Okay. And subtract 40 from negatively standard cell. Since 4 cell is a leaving cell, we need not write 4 cell. Okay. We have to write this cell only. That is 3 cell only. Okay. In 3 cell, previous allocation 80, and it is negatively standard cell. So subtract 40. 80 minus 40, 40. So 3 cell 40 and circulate. Okay. And the other cells remain same. So what are the other cells? 1 3 cell remain same. This is 1 3 cell remain same. That is 90. Next. 2 1 cell remain same. 30. Next. 2 3 cell remain same. 20. Next. 5 1 cell remain same. 50. This is the new basic feasible solution. Okay. So count the cells. So these 3, 3, 6, 7. So 5 plus 3 minus 1, 7. Okay. So we got all basic cells. Okay. So here, observe the previous solution and present solution. These 3 cells remain same. Here, these 3 cells remain same. In the previous table and the present table. And this cell is also same. Okay. So only these 3 cells change. Only these 3 cells change. Okay. Now, what is the change in the transportation cost? For these 3 cells, the transportation cost remains same. Okay. Since they do not change, the amounts are not changed. Okay. Right. Here, observe in the previous. Here there is no transportation. At present, transportation is 40. Okay. That means 40 into 7. Transportation increased here. 40 into 7. That is 280. Next, here observe the cell. Here previous allocation 20. Now the present allocation is 60. That means here also 40 units are increased. So transportation 40 into 5. Okay, 200. So here 7 into 40. 280. Here 40 into 5, 200. So total transportation cost change in these cells is 480. Okay, right. Next, observe these two. Here, these 2 cells. Here, previous transportation 40 units. We have removed this. That means 9 into 40, 360. So we have to reduce this transportation cost. 360. And here, previous allocation is 80. Now the allocation is 40. So we have to reduce 40 units here. So 40 into 3, 120. So total 480. So this is reduced transportation cost. And this is increased transportation cost. Both are same. Okay. So that means there is no change in the transportation cost. Okay. So the present solution automatically an optimal solution. Since there is no change in the transportation cost to the previous solution and this solution, so this solution is also an optimal solution. Since the previous solution is an optimal solution. Okay. So write the alternative optimal solution is, so these 3 cells remain same. First 3 cells, x1 390, x2 130, x3 320, then x3 140. This is x3 140 and x3 240. And x4 to 60. And x5 and same dummy, that is dummy. So the minimum transportation cost, same, you get same. So 5 into 90 plus 12 into 30 plus 4 into 20 plus 7 into 40 plus 3 into 40 plus 5 into 60. You get same. 15, 90, hundreds. That is 1,59,000 rupees. So you get same minimum transportation cost, but the optimal solution may differ. Okay, so this is another transshipment schedule for the company with the same minimum transportation cost. Okay, so this is the way to find multiple optimal solutions to a transportation problem.